Now in this video, we are going to learn about Newton's second law, perhaps the most important law in whole of physics. First, let us try to understand what is momentum. A truck is moving with a velocity of 10 meters per second. It hits you, it will cause a lot of damage. A cycle moving with high velocity can also cause a lot of damage. So there is some property that is related to both mass and velocity that denotes the quantity of motion contained in a body. This is called momentum, linear momentum. Linear momentum is a vector quantity. It is given by the product of mass and velocity. P vector equal to mv vector. Now what is Newton's second law? Newton's second law tells us that the rate of change of momentum is directly proportional to the impressed means applied, impressed force, and takes place in the same direction as the force. So rate of change of momentum mathematically is dp dt. This is directly proportional to force. So this is what Newton's second law tells us. If this is proportional to this, it means force will be proportional to dp dt. In appropriate units, we can write force as dp dt. Now what is momentum? mv. So we can write F equal to d dt of mass into velocity. Now if mass is constant, okay, don't think always mass is constant. When you study rockets, we'll have variable mass. But for the time being, let us assume that mass is constant. This mass will come out of the differentiation and we'll get F equal to m dv dt. And what is dv dt? Acceleration. F equal to ma. This is the most important equation in whole of physics. Force equal to mass into acceleration. This is what kind of equation? This is a vector equation. And any vector equation is equivalent to three scalar equations. The force component along x-axis will be mass into acceleration component along x-axis. Fx equal to max. Same way, Fy will be may and Fz is maz. Now you may think why we are writing this. The reason we are writing this is very important. A force along x-axis will cause acceleration only along x-axis. If we apply a force along x-axis, there is no way it can cause acceleration along y-axis or z-axis. Because these axes, x, y and z, are independent of each other. And that makes things simple for us. When you look at x-axis, we need to look at only x-axis. We don't need to worry what is happening along y or z-axis. When looking at y-axis, look only at y-axis. And when you are looking at z-axis, look only at z-axis. A force along x-axis is not going to cause acceleration along any other direction other than x-axis. This is very, very important. Now here we have got mass. What is mass? Right, in school they teach you that mass is quantity of matter. Then how does it relate to 1 kg, 2 kg, 3 kg? So mass basically is defined by Newton's second law. There are two kinds of mass actually. First one is inertial mass, that is defined by Newton's second law. And we have got gravitational mass, that is defined by Newton's law of gravitation. So what is this inertial mass? This is here. Mass is a scalar quantity that relates the force acting on a body with the resulting acceleration. If a force of 1 Newton produces an acceleration of 1 meter per second square, then the mass is 1 kg. Very easy. If a force of 2 Newton is producing an acceleration of 1 meter per second square, then the mass is 2 kg. So this mass comes from this equation, F equal to ma. Gravitational mass comes from Newton's law of gravitation, which we are going to learn in detail later. Newton's law of gravitation tells us force between any two particles of mass m1 and m2 is given by F equal to gm1 m2 by r square. That is gravitational mass. This is inertial mass. For us, both are same. Right? So mass is a scalar quantity that relates the force acting on a body with the resulting acceleration.